So mock exam related to 9 to 12. The first three statements about the element carbon, nitrogen, and sulfur. So carbon is there, nitrogen is there, and sulfur. So they are in the groups next to each other in the periodic table. So yes, statement, this is group 4, nitrogen is group 5, and oxygen is and sulfur are in group 6. So first statement is correct. Why it is correct? Because they're not saying next to the group is next to each other. Like carbon is there group 4, nitrogen will be there group 5, and oxygen will be there group 6. So with reference to that, statement 1 is correct. Statement 2, their neutron to proton ratio are 2:1. That is not correct. Why? Because, like example, carbon is 6 and 12. So how many neutrons are there in carbon? The carbon is having 6 neutron and 6 proton. So the ratio of neutron to proton is 1:1, not 2:1. Same thing for nitrogen, which is 7 and 14. So nitrogen contains 7 neutron because 14 minus 7, 7 neutron and 7 proton. So when we take the ratio will be 1:1. And what about sulfur? Sulfur is 16 and 32. So when we take, this will have 16 protons and it will have 16 neutrons. So the ratio between neutron and proton is also 1:1. So according to this statement, the ratio should be 1:1, but here they say 2:1. That's why this is not correct. If it was a nucleon number to proton number, then it is 2:1. But neutron to proton, it is 1:1. And they each form an acidic oxide. That is true. Why? Because they are non-metal. And what is the characteristic of a non-metal? It can form either acidic or a neutral oxide. So with reference to that, C should be the right answer. Then what is the property of halogen? The term halogen means salt former, and group 7 elements are known as halogens, such as fluorine is there, chlorine is there, bromine is there, and iodine. So the atom decrease in the size, that is wrong. Atomic size for all the elements and down the group increases. Their melting point increases. That is true because fluorine is a gas, chlorine is a gas, bromine is liquid, and iodine is solid. That's why B is the right answer. The next question, question 3. The part of a periodic table shows the position of 4 elements. These are not elements' actual symbols. Which element will have the high melting point and variable oxidation state? So high melting point and variable oxidation state, these are characteristic of what? These are the characteristic of transition
elements.
Transition element. So where we can find the transition element? So we can find transition element. C will be the right answer. You can also use a chat or your mic to answer for any question if you understand. Some properties which make the element different from each other are listed.
So Mr. State 2 is right.
When we check like which make like some properties which make element different from each other are metallic character, and which properties increases as we move across the period. Like in a periodic table on the left hand side, you will find mostly metals are there. On the right hand side you will find non-metals. So what happened to metallic character? Metallic character does not increase, the metallic character decreases. Number of electron shells in an atom.
Yes, it increases.
Number of electron shells. Why? Because like across the period is representing the number of electron shells, not number of electron shells across the period remain the same. When you move across the period, example, if this element is having 2 shells, the next element will also have 2, another will have 2, because the period number represents the number of the shells. So number of the shells or electron shell does not change. The number of protons in an atom, how many protons are there in an atom, that increases because the atomic number increases. And total number of electrons in an atom will also increase. So 3 and 4 are the right statements. Question 5, which equation shows a reaction that occur at a room temperature? Remember, the more reactive. Why 2 is wrong in the previous question? Why 2 is wrong? Because when we move across the period in a periodic table, the number of electron shells remains same because the period number represents the number of the shells. So as the element is there, period 2, like example, the period 2 elements such as lithium is there, beryllium is there, boron is there, carbon is there, nitrogen, oxygen. So as they all belongs to period 2, the second period, so what is the common between them? That they all will have the 2 shells. The number of the shells will be same for both of them, for all of them. Only what happens, because their groups are different, as this is group 1, so it will have 1 electron, this will have 2 electrons, this will have 3 electron, carbon will have 4 electron, nitrogen 5 electron, oxygen 6, and so on. So the number of electron shell does not change across the period. It remains same. So in question 5, always the more reactive halogen displaces the less reactive halogen from its compound. So we have chlorine, fluorine, chlorine, bromine, and iodine. As we go down the group, the reactivity decreases. They become less reactive. So first, when we check bromine with chlorine, because bromine is less reactive, so it won't displace. Then bromine with iodine. Bromine is more reactive than iodine, so bromine will displace iodine. As a result, it will produce sodium bromide and iodine molecule. And iodine, because it is less reactive, so it is not able to displace the chlorine or the bromine from its compound. So the more reactive halogen displaces the less reactive halogen from its compound. The diagram shows part of a periodic table, which element has a highest proton number and which element has a large number of valence electrons. Look, highest number of proton.
So, Mr. Valence electrons, it's group 7.
Group
and
7.
highest proton number. Yes, and the highest proton number, it's.
So which element? Lithium, calcium, or chlorine? Lithium is 3.
Yes, so highest number of valence electron, it's group 7 is chlorine.
No, chlorine is having 17 electrons, 17 protons, 17 electrons. Calcium atomic number is.
No, the valence electrons.
The valence electron is chlorine. And number of electrons, number of protons are more for calcium. So that's why B is the right answer for this. For any question, if you want me to repeat, just let me know. So I'll repeat that. A lump of element X can be cut by a knife. So what is this characteristic? This is actually a characteristic
Sodium.
Of group 1 element. Can be
group 1
of
potassium.
So group 1, this is group 2 element. This is a transition. This is also group 2. This is a transition element.
So potassium.
So potassium is their group 1 element. So even if an element or a metal can be cut by a knife, this gives an indication that it is a group 1 or alkali metal. Question 8. Which statement about the properties of some elements is correct? All noble gases are unreactive due to having 8 electrons in outer shell. That is wrong.
Yes, mister. That's
no. Why it is wrong? Because helium is also a noble gas, and helium
yes,
contains
and have 2
only. Because the first helium is having only 1 shell, and that first shell is having 2 electrons. The reason is because they have complete shell. Not all have 8 electrons. When we check group 7 elements, astatine is expected to be a black solid at room temperature. That is true. Because fluorine, chlorine, bromine, iodine, and then astatine, all these group 7 elements exist as a diatomic molecule in which fluorine and chlorine are existing as a gas at room temperature. Bromine is a reddish brown liquid. Iodine.
Yes, and this liquid and the last one gas.
No,
Sorry,
no.
solid.
Solid. So gas,
Sorry.
gas, liquid, and solid. So the melting point increases. So the substance become solid as we go down the group 7. So for group 7, melting point increases as we go down, whereas group 1, the melting point decreases as we go down. In question 9, element X and Y combine to form an ionic compound. So if they are forming an ionic compound, it means one should be a metal,
One metal and one non-metal.
another non-metal. Element X have more proton than atoms of Y. The atoms of X have more proton, but this does not give an indication if it is having more protons. But this does not give an indication about the whether an element is a metal or a non-metal. Element Y have more valence electrons. When there are more valence electrons, what does it mean? Because if number of electrons are more in the last shell, the likely the element will be a non-metal. Because like for a non-metal, group 4, you will find they have 4 electrons. Group 5, you will find they have 5 electrons.
Will be 5.
Group 6 will have 6. Yeah, so the elements which are having more valence electrons, greater number of valence electrons,
it's not metal.
Are likely to be a non-metal. So
or negative charge.
Yeah, negative charge will be there. So this gives an idea that this Y is a non-metal and X is a metal. And this first statement, what it gives an idea, if it is having more proton, so as the proton number increases, the position of element changes in the periodic table. I will show a periodic table. This is the image of the periodic table. Look, if element is a non-metal, the right hand side you will find non-metal, on left hand side you will find metal. Now example, say this element was chlorine, say element Y was chlorine, and in the second statement, in the first statement, they say X is having more proton. So when the proton number increases, like here we have non-metal, and the left hand side we will find metals. So this is why the non-metal, as the proton number increases, the next metal will be in the another period. Because if the metal is having a proton number less than the non-metal, then it will be in the same period. But if it is having more protons, so it means it will be in the next period, or the metal will have more shells than the non-metal. So what this gives an idea? First thing, the second statement, atom Y have more valence electron than atom X. So it gives an idea that Y is a non-metal, where X is a metal.
X is a metal.
And then this statement, atom X have more proton than Y. It means when it is having more proton, if metal is having more proton than non-metal, so it is in another period, or it is having more shells, because more protons means next period or more shells, and this will have few shells because few protons are there or less number of protons. So which statement is correct? The ion of, and remember, because it's a metal, so metal tend to form a positive ion and non-metal tend to form a negative ion. So ions,
the first one is wrong.
Yeah, ion of X are negatively charged. That is wrong, because it cannot be negatively charged. It should be positively charged. Then atom of X have more electron shells than Y. That is true, because it is X is having more protons. So
because more shells.
Yeah, greater number of protons, so more electrons will be there. As the number of electron increase, the number of electron shells will also increase. Why C is wrong? X and Y in the same period. They cannot be in the same period. Why? Because look, Y is a non-metal that we identify. So for X to be in the same period, so the X should have a less protons. When we move in the periodic table, if the metal and the non-metal, if they belongs to the same period, like if I say we have sodium and chlorine. So if the metal and the non-metal belongs to the same period, the number of protons on metal should be less than number of protons on the non-metal, if they belongs to same period. But in this question, because the metal is having more proton, that's why the metal does not belongs to the same period. It belongs to another period, or it is having more electron shells. So, and they cannot be in the same group. Why? Because one is a metal, one is a non-metal. That's why with reference to that, B is the right answer. The next question. The element in group 1 of a periodic table shows a trend in both reactivity and their melting point. Rubidium is in group 1. So when we check the group 1 element, these are the group 1 element which include lithium, sodium, potassium, rubidium, cesium, and francium. These are the elements. So when we check which statement about the as we go down the group, what happened to the melting point? Like we have lithium, sodium, so as we go down the group, lithium, sodium, potassium, and rubidium. So what happened to the reactivity? Reactivity increase. What happened to the melting point for group 1? The melting point decreases as we go down the group. So it has a higher, rubidium cannot be higher because the melting point decreases as we go down the group, for especially for group 1. It reacts with water to produce acidic solution. That is totally wrong because group 1 are known as alkali metals, and alkali metals does not
So,
form
Mr. It's D.
Yeah, it reacts with water to produce oxygen. That is also wrong. It does not produce oxygen gas. Alkali metal, when react with water, it gives off hydrogen gas. And it is more reactive than potassium. That is true as we go down the group. For group 1, the group 1, the reactivity increases as we go down the group. So rubidium is more reactive than potassium. So D is the right statement. Question 11, which is not a property of alkali metals? So which is not the property of alkali metal? They are soft and can be cut by knife. That is true because alkali metals, we can easily cut them by a knife. The second one, they corrode rapidly when exposed to oxygen, like they react quickly or fast when they are exposed to oxygen in air. That is also true. Alkali metals are highly reactive. They produce acidic solution. That is totally wrong. Alkali metal does not produce acidic solution. Alkali metals produce alkaline solution or a basic solution which turn the universal indicator blue or purple. And they react rapidly with water to produce hydrogen. That is also true. So statement C is incorrect. Question 12, an element melts at, the element is having a high melting point, high density, and forming a colored compound. So which position likely we can find this element? Where is in the periodic table we can find? So we can find this will be a transition element. So C will be the right answer. In question 13, an element does not conduct electricity but exists as a diatomic. So if it does not conduct electricity, means it is not a metal. So it cannot be A, it cannot be B, because metal cannot conduct metal can conduct electricity, non-metal cannot, except for Graphite.
Mr. Diatomic, so it will be halogen C.
Halogen. So that's right. So C will be the right answer because group 8 element are not diatomic, they are monoatomic. Like you will find one atom. So diatomic, it will be halogen or a group 7. Solution of halogen and a sodium halide are mixed. Which mixture darken in color because of reaction occur? So always remember the more reactive halogen displaces the less reactive halogen from its compound. As we go down the group, the reactivity decreases. So first bromine with chlorine, will they react? No. Why? Because bromine is less reactive. Bromine with fluorine, will they react? No, because bromine is less reactive. Chlorine with fluorine, will they react? No, because chlorine is more reactive than chlorine is less reactive than fluorine. But chlorine with iodine, will they react? Yes, because chlorine is more reactive, so it will displace the iodine and the reaction will occur or take place. In question 15, the diagram shows a light bulb. What is the reason why we use an argon? Argon group 8 element are unreactive.
Unreactive, Mr. with wind or air, sorry.
Air, oxygen, metal, they don't react with. So advantage is that if they don't react, so they will make it this environment inert. Otherwise, instead of argon, say if it was air was present, air contain oxygen, which is an active component, so oxygen might react with the tungsten and reduces the strength of this tungsten. So why we don't use air, we use argon? Because argon does not react. So if argon does not react, what is the advantage? This filament, which is made up of a metal tungsten, can last for a longer period of a time. Like it will remain there for a very long time. So argon is a good conductor of electricity. That is wrong because it's a non-metal. Argon is more reactive than air. That is totally wrong. Group 8 elements are not reactive. The filament glow more brightly. That does not, because the brightness, or it depends on how much voltage we apply or the current is passing, not about the presence of argon. The filament will last for a longer, like filament will remain there for a long period of a time, as a filament does not react. As argon is unreactive gas, it does not react. So it will reduce the,
Mr.
yes.
If there was oxygen and it reacts with the filament, it will burst, Mr.
If it reacts, the filament will blow. Like the strength of a filament will decrease, so easily it will, because of the heat energy, it will melt easily.
Yes, okay, Mr.
In question 16, the elements in a group of a periodic table shows the following trend. The element with the lowest proton number has the lowest reactivity. Like remember down the group, like the proton number increases. So lowest proton number will be element at the up and the highest proton number will be element at the bottom. So what they said that element with the lowest proton number have low reactivity, like they are less reactive and this will be more reactive. So for which group the reactivity increases as we go down? There are two groups you have studied. You have studied group 1 and you have studied group 7. So group 1, the reactivity increases as we go down, whereas for group 1, as we go down the group, the reactivity increases. They become more reactive. And for group 7, reactivity decreases as we go down. So the element with the lowest proton number have lowest reactivity. So this gives an idea that it should be a metal group like group 1. These elements are forming a basic oxide, metal oxide, group 1. The density of element increases as we go down. That is also group 1, and melting point decreases. So all are these actually the characteristic of which group? These are the characteristic of group 1. For group 1, the melting point, as we go down the group, it decreases, the density increases, they form basic oxide, as well as the reactivity increase when we go down the group. Brass is an alloy of two metals. So brass is actually alloy of what? It is alloy or a mixture of zinc and copper. So which row gives the correct use of the two metals? Like what is the use of zinc and what is the use of copper? So for zinc, we can use galvanizing, and for copper, we can use for electrical wirings as well. It can use or used to. So when we check the options, So if the first metal is copper and the second metal zinc, because what is the use of copper? Copper can be used for electrical wiring, and metal 2, if it is zinc, then can be used for galvanizing. It cannot be like galvanizing. See, when you write check the uses, say this is because we want a brass, which is an alloy of zinc and copper. So we want to check what are the uses mentioned here for which element. Used for electrical wiring, we are using copper. Used for galvanizing, we use zinc. Used for galvanizing, zinc. Used for making aircraft bodies, aluminium. Used for making aircraft, aluminium. Used for making cutlery, stainless steel. Or you can say the element which is present is iron and carbon, are carbon. Making for cooking pans, cooking utensils are there. It can be stainless steel, it can be aluminium. And electrical wiring, that is copper. So because we want the use of copper and zinc, so option A is correct. Why? Because it is giving an explanation about the use of copper and zinc. Iron is extracted from an ore hematite in the blast furnace. Hematite contains silicon 4 oxide as an impurity, which reacts with this impurity to remove. Like what is reacting with silicon oxide to remove this? So that is actually calcium oxide. When calcium oxide react with silicon 4 oxide, so it will form calcium silicate or it will form a slag. So A is the right answer, that calcium oxide react with silicon 4 oxide. And calcium oxide is a basic oxide, where silicon 4 oxide is an acidic oxide. The reaction below is called a thermite reaction. Thermite reaction, what happened, the more reactive metal displaced, because when you check the reactivity, aluminum is more reactive than iron. Okay, question 18. Look, in the question 18, they ask, this is related to the process, the whole process of extraction of iron. If you remember the extraction of iron, what we do in extraction of iron, first the carbon react with oxygen to give carbon dioxide. Then the carbon dioxide react with more carbon to form carbon monoxide. Then this carbon monoxide is a reducing agent. It will react with ore of the iron, the hematite. It produces iron metal and carbon dioxide. Then there is also impurity, sand is also present. So how this sand is removed from this? So for removal of a sand due to heat energy, the calcium carbonate decompose into calcium oxide and carbon dioxide. So this calcium oxide, which is a basic oxide, react with silicon 4 oxide to form CaSiO3, which is called a slag. So how this sand is removed from the mixture is by reacting with a substance called calcium oxide. So this is related to memorizing the series of reactions which are used in the extraction of iron. The reaction below is called a thermite reaction, which pair of a substance react in a similar way. As you can see, aluminum is more reactive, so aluminum displaces iron from its compound, form iron and aluminum oxide. So when we write the reactivity series, we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So iron and magnesium, will they react? Iron cannot displace magnesium. Iron is less reactive. Iron with zinc. When you check, iron is here. Yeah, it won't, because iron is less reactive. Magnesium with copper. So you have magnesium here and copper below. So magnesium more reactive. So magnesium can displace the copper. As a result, it produces magnesium oxide plus copper metal. So this reaction will occur. And zinc and aluminum, when we check aluminum and zinc, so zinc cannot displace aluminum because zinc is less reactive than aluminum. So the idea was like in which reaction or which reaction will occur due to the difference in the reactivity of the two metals. In question 20, one method of preventing rusting of iron is to keep oxygen away from the surface. Which way of a rust prevention does use this method? Like how we can prevent rust, we can prevent which does not use this method. There are different ways to prevent rust. What we do, we normally paint the structure. We can use oil or a grease, or we can electroplate, or we can use sacrificial protection. These are different ways to prevent iron from rusting. So all these methods, like when we coat, like example, say this is a piece of iron. If we coat the iron with a grease, like there is a layer of a grease on the surface of iron, so that grease does not allow the oxygen to interact, oxygen or water vapor to interact with iron. So the question is which way of a rust prevention does not use this method? Because one method of preventing is keeping the iron away from oxygen. So this method is keeping the iron away from oxygen. This is also. But sacrificial protection, when we coat with a more reactive metal or connect the iron with a more reactive metal, we don't, iron is exposed to oxygen, but still the iron which is exposed to oxygen does not react with oxygen, as the more reactive metal has a greater tendency, like we have a more reactive metal here. So if we have oxygen and water in the atmosphere, even though iron is open to the atmosphere, but it does not react, as a more reactive metal has a greater tendency to lose electron compared to iron. So connecting the iron to more reactive metal does not use this technique of exposing the iron to oxygen. Like iron is exposed to oxygen, but other techniques such as paint, oil, or electroplating, we are actually preventing the oxygen to interact with iron. Question 21, the diagram shows how a water is treated in a suitable, which makes it suitable for drinking. We store the water. Then what we do, we filter, because insoluble impurities are removed by filtration. So which process should occur here? That is filtration, then chlorination, and then we use it for drinking. Sometime you will find a structure question. They ask, what are the two methods, what are the two processes required to make the water suitable for drinking? So the correct answer is filtration as well as chlorination. So first we filter and then we chlorinate. In question 22, the nitrogen monoxide is produced in the car engine when the petrol is the gases from a car engine are passed through a catalytic converter. The catalytic converter convert the nitrogen monoxide, react with carbon monoxide to form nitrogen and carbon dioxide. Which statement is not correct? So basically what happened in a car catalytic converter, carbon monoxide and oxides of nitrogen. So it produced nitrogen gas and carbon dioxide. So the carbon monoxide, when we check the change, carbon monoxide turn into carbon dioxide. So addition of oxygen, oxidation, and removal of oxygen is reduction. So which statement is not correct? Carbon monoxide is oxidized. That is true. Carbon monoxide produced by complete combustion. That is the wrong statement. It should be a word incomplete combustion, not complete, because oxides of carbon monoxide is only produced by incomplete combustion, not by complete combustion. Nitrogen monoxide formed by reaction of nitrogen and oxygen at high temperature. That's true. And nitrogen monoxide is reduced in a catalytic converter. That is also true.